Hello, sixth graders. We are on the lesson Many Ways to Measure using ratio reasoning to convert. Talk about measurements today. If you're following along in your textbook, you're looking for M2-165. M2-165. All right, getting started. Customary to whom? It says you've learned about the relationships between inches and feet, feet and yards, quarts and gallons, meters and millimeters. So knowing what we know about customary system, which is what we use in the U.S., and the metric system, name a unit of measurement that we would use to measure the following. So your height. What would we use to measure your height? Hopefully you'd say feet, maybe even inches. In the metric system, we would probably use meters or centimeters. The length of your pencil would probably be straight up in inches, and in the metric system, centimeters. Distance from your school to the beach, well, we're really far from the beach, but even if we go to a local lake or something, we could count it in miles, and if it's the metric system, kilometers. The weight of your math book would probably be in pounds or ounces. In the metric, maybe kilograms or grams. Amount of water in a bottle, we measure that in fluid ounces or in liters. And the amount of water in a swimming pool would probably be a little bit bigger, gallons, and then maybe kiloliters in metric. Circle the most appropriate measurement for each item. The weight of a dog. Well, I don't do... He's not going to weigh a ton. He's not liquid. So 18 ounces or 15 pounds. I know there's 16 ounces in a pound, so I think 15 pounds would make sense. The amount of gas in a car's tank. I know these are all liters, and like a 2-liter bottle of pop. So kiloliters are way more than that. They're going to be way too big. And milliliters are going to be too small, so I think 55 liters would probably make sense. The height of your classroom, well, it's not going to be a mile high. 2 yards is only 6 feet. That's not very tall. 90 inches, that isn't real tall, so I think 12 feet would probably be the best one. And the height of a basketball hoop. Centimeters are really kind of small. Millimeters are really small. A kilometer is similar to a mile, so no. So I think in 3 meters for that one. All right, let's keep going here. Reasoning about unit conversions. You can use more than one measurement to describe the same length, weight, or capacity. For example, you may say that a football field is 100 yards long or 300 feet long. You could say yards or feet. You could also say that the football field is 90 meters long. In each case, they are the same lengths, you just say them in different ways. Anytime you have to go from one to the other, we call that converting. To convert a measurement means to change it to an equivalent measurement in a different unit. When would we maybe need to do that? Well, football field example, maybe even your height. If we had to say you're so many feet in inches, maybe you just wanted to give it in inches, something like that. Maybe you can think of another one as well. So before we start converting, it's useful to estimate the number of units in a conversion. A few estimates comparing US to metric are below. So 1 meter is about the same as 1 yard. 1 inch is about 2.5 centimeters. 1 kilometer is half of a mile about. A foot is like 30 centimeters. A liter is like a quart, and a kilogram is a little more than 2 pounds. So those are some good things that we might refer back to. It says use the estimates given and your knowledge of US and metric custom measures to answer the following questions. The numeric, the number value of which measurement would be bigger or greater. If you're going to measure a table in inches or feet, will you have a larger number of inches, or we have a larger number of feet? You'll have a larger number of inches on that one. Try the rest on your own, and then we'll come back and talk about it. Okay, in B, the length of a table in meters or centimeters, that's kind of like the inches and feet. Centimeters are smaller, so there's going to be more of them. The length of the table in meters or yards. Meters and yards are about the same. They're really close. And a yard is just a little bit smaller, so it's going to be slightly more yards. The distance from school to your house in miles or kilometers. We said a kilometer is like half of a mile, so there's definitely going to be more kilometers. The weight of your math book in kilograms or pounds. There's about 2.2 pounds for 1 kilogram, so definitely is going to be more pounds numerically than the other. How do we decide? Well, the smaller the unit, the more of them there'll be. All right, estimate your measurement conversion. The distance to Toronto is 548 kilometers. About how many miles? Well, I know 1 kilometer is about a little more than half a mile. So if I have 548, I'm going to take half of that, and half of that equals 274, give or take. Notice the squiggly lines that I gave, that's approximately 2, okay? So we use that when we don't have an exact equals. You order 5 kilograms of food pellets for your guinea pig. About how many pounds? Well, I know 1 kilogram is about 2 pounds of food. So if I'm ordering 5 kilograms, I'd do 5 times 2 and say about 10 pounds of food. And then what did we use as our strategies? Well, we had to use some conversion and some multiplying or dividing to come up with those. Let's move on. Because most conversions compare to quantities using multiplicative strategies, the conversion estimates provided and the conversions within systems that you already know can be written like a ratio. They can be written in ratio language, like you see here, or they can be written symbolically, and there they show you what that squiggle lines tend to mean. All right, so it says when you can study that table there to understand about what goes from what to the other units. When a conversion ratio is presented for use in converting between units of measure, it's often written as an equation. 12 inches equals 1 foot. However, it can also be written as a ratio in fractional form. 12 inches to 1 foot. So it says rewrite each common conversion using ratio language and as a ratio in fractional form. You're just going to write them in fractional form. And let's talk about our ratio language. How could we say this one? We could say for every 3 feet, that equals 1 yard. That's ratio language. For B, we could say for every 5,280 feet, that equals 1 mile. For C, we could say for every 1 pound, that equals 0.45 kilograms. For D, you could say for every 4 quarts, there's 1 gallon. So that's ratio language. Now go ahead and write each ratio in fractional form. Let me do the first one for you. It'll look like this. 3 feet to 1 yard. That's a ratio in fractional form. Go ahead and do B, C, and D. Pause the video and then come back. For B, you could have 5,280 feet for 1 mile. You could have 1 pound for C for every 0.45 kilograms. And you could have 4 quarts for every 1 gallon. Those are written in fractional form like a ratio. We're going to use these to set up a proportion to make our conversions. Oh, 2 more there. We forgot them. 1 meter for 100 centimeters and 1/1000th of a meter to 1 millimeter. Now this one looks kind of funny because this is what we call a complex fraction. It's a fraction within a fraction. That's okay. It's legal. We can do that. You'll use those more as you get into your higher algebras. All right, let's keep going. Using a double number line to convert units. So we got, again, coming up with equivalent ratios. It says when you learned about ratios, you learned how to use a double number line to determine equivalent ratios. You can also use double number lines to convert from one unit to the next. Although you may not have realized it before, rulers are set up as double number lines. They can be used to convert between inches and centimeters. Excuse me. It says determine which scale represents inches and which represents centimeters. I know centimeters are smaller than inches, so this side represents centimeters and this side represents inches. How did you decide? Well, like I just said, I knew the smaller units, centimeters were smaller than inches. All right, use the ruler as a double number line to determine each approximate conversion. So notice down here, they're all approximate. We're using this approximation symbol and not an equal sign. Okay, so 1 centimeter is about how many inches would that be? 1 centimeter, come down here, and these lines are eighths. So there's 1, 2, 3, 4, 5, 6, 7, 8 eighths. So this would represent 3/8. And 1 inch represents how many centimeters? Well, here's our inch. And if we go up here, we find that it is about in the middle of 2 and 3. And with meter or centimeters, we write like decimals. So we'd call it 2.5 about, or 2.5. 5 centimeters is about how many inches? Here's centimeters. That looks like it's about 2 inches. And 3 inches is about how many centimeters? 3 inches. Looks like it's just past the 7.5, so I think I would call it probably 7.6 approximately. So again, you can use this built-in double number line to help convert from inches to centimeters. Here's another problem. You're baking cookies at your friend's house. After searching the cupboards and drawers, you can't find the measuring cups, but you can find a tablespoon. Use the double number line to determine how many tablespoons you'd need of each ingredient in the recipe. All right, here's what we know. There are 16 tablespoons in 1 cup. That's what we know. All right, so if we fill in some other things on our number line here, halfway, let's go 1, 2, 3, 4, 5, 6, 7, 8. So 8 tablespoons would be a half a cup. If we went 8, 1, 2, 3, 4, 5, 6, 7, 8, that'd be a 1.5 cups. And 16 plus 8 would be 24 tablespoons. Oh, I could label it down there. And then 1, 2, 3, 4, 5, 6, 7, 8. We'd be up to 32 tablespoons would equal 2 cups. All right, so we filled in some of these. Let's see if we can answer them. 2 cups of sugar. If you've got 2 cups of sugar that you need, how many tablespoons is that going to be? Well, that's going to be 32 tablespoons of sugar. How about 1 3/4? Well, here's 1.5, here's 2. Let's go 1, 2, 3, 4 more. That's about 1 3/4. And here's 24, 25, 26, 27, 28. So that's going to be 28 tablespoons. And let's see, a half a cup of raisins would then equal half a cup, 8 tablespoons of raisins. Good. It says, suppose you had found the cup, but not the tablespoon. Use the double number line to determine how many cups you'd need if the recipe called for 2 tablespoons of vanilla. Well, let's fill this in up here. 2 tablespoons. 3, 4. There's 4 tablespoons. 1, 2, 3, 4. And half of a half is a fourth. And then this would be half of a fourth. I know half of a fourth would be an eighth. So I would then need 1/8 of a cup for my vanilla extract. All right, so that's how we can use a double number line to help us convert. Let's keep going. We're going to skip this next little section here. Let's go to using ratio tables and scaling to convert units. We know how to do this, scale up, scale down, and we can use tables to help us determine equivalent ratios. So we've got pounds and ounces. I want you to pause this video and see if you can do your best to fill out this ratio table to help you come up with the equivalent units. Okay, hopefully you took some time to fill out this chart and see if you can figure it out. Let's see, a couple of things here. We can go 1 to 2. We times by 2 to do that. And so 16 times 2 would be 32. To go from 16 to 4, we would divide by 4. So 1 divided by 4 would be a fourth. Okay. What would I multiply a fourth by to get to 1 1/4? Well, for me, let's see. I would probably take 1 1/4 and I divide it by a fourth to see what I have to multiply by. You might have a different strategy. I'd do 4 times 1 is 4 plus 1 is 5/4 times. I'd flip this to divide it. And then it simplifies and I'm left with 5. So I'd have to multiply this by 5. And so I'd multiply this by 5. This would equal 20. To do a half, I know to go from, I could take half of 1. So half of 16 would be 8. To get the 6, I would probably do, well, if I know 1/4 pounds are in 4 ounces, how many would be in 2 ounces? I would divide by 2. And so if I take 1/4 divided by 2, it's like 1/4 times 1 over 2, which equals an eighth. And then if I want to try to get to 6 ounces, I would times by 3 and times by 3. So that would give me 3/8 for this one. And then let's see, I know I can do 20 times 40. I could take it times 2. So 1 1/4 times 2 would be like 5/4 times 2 over 1. And that's 5/2, which changes to 2 1/2. Your strategies may have been different, but hopefully you came up with the same numbers as I was able to do in my ratio table. Let's move on. We're going to skip this number 3. Let's look at this one for a second. There's some you might refer back to this chart, so you probably want to star it and kind of note the page number. It gives you some of the common conversions to go from customary to metric in length, like inches to centimeters, centimeters to inches, feet to centimeters, meters to feet. In mass, which is grams and pounds and ounces, and capacity, which is like liters, pints, quarts, gallons, that kind of thing. So we're going to refer back to this for the next couple problems. So just like we can do a ratio table, we can also scale up to come up with conversions and know how to find the equivalent. So for example, this question says, you can use scaling up to determine how many kilograms are in 2.5 pounds. Because you want to determine the number of kilograms for a specific number of pounds, you use the conversion rate of 1 pound equals 0.5 kilograms. We can get that right from here. 1 pound equals 0.45 kilograms. We don't have to memorize those things because we can use a table like this to help us. So if I can scale up to show how many pounds equals 1 kilogram or vice versa. Let's try it out on a problem just like down here with our school cafeteria. The school cafeteria has 8 very large cans of tomato sauce for making pizza. Each can contains 2 gallons of sauce. So 1 can, 2 gallons. Okay? Is there more or less than 50 liters of sauce in 8 cans? All right, so I'm talking liters and I'm talking gallons. I got to know a conversion between liters and gallons in order to be able to do this problem. Well, what do I know? If I look back on this chart over here, I can see, where are my gallons? Right here. I can see that 1 gallon is 3.79 liters. So let's go here. 1 gallon is 3.79, 3.79 liters. If I write it like a fractional ratio, I can say 1 gallon, 3.79 liters. Okay? Well, I have a 2-gallon can, so I want to take it times 2 to get 2-gallon can. So I take this times 2, and I can go ahead and use my calculator, no problems there, and I would end up with 7.58 liters. All right. Now the question's asking, are there more or less than 50 liters, and there's 8 cans? Okay, so this is 1 can. So I have 8 cans I've got to deal with. So 8 cans, I'm going to scale up by multiplying by 8. I'm going to end up with 16 gallons. And I'm going to multiply this by 8, and I'm going to end up with 60.64 liters. Is this more than 50 liters? Why, yes, it is. Yes. More than 50 liters. So this is how we can use scale up and scale down to come up with converting units. I want you to try the next one on your own. Pause the video. If you have time, do try actually both of them, and then we'll go through those together. Okay, hopefully you attempted to solve both of them. The question asks, Tyrone, the quarterback for the Tigers football team, can throw a football 40 meters. Jason, quarterback for the Spartans, can throw a football 45 yards. Who can throw it further, and how do you know? When I look back at that chart, I find that 1 meter is the same as 1.09 yards. All right. So now I just have to set up a proportion, and I have to match units. So meters, right here, 40 meters. So I'm going to put that on the top with meters, and I'm going to figure out how many yards is that. Well, I scale up to do that, so 1 times 40 will get me there. 1.09 times 40 will get me to 43.60 yards. Okay, so what does this tell me? This tells me that Tyrone, if they're both throwing in meters, Tyrone can throw 40 meters, and that equals 43.60 yards. So Tyrone can throw 43.60 yards. Okay? Jason can throw 45 yards. Who throws further? Now I can tell because they're in the same unit. Jason can throw further. You could have changed yours both to meters, and that would have worked as well. Molly says she's 1.5 meters tall. Shauna's 5 feet tall. Molly says she's taller. Shauna disagrees. Who's right? All right, so if you looked back at that chart, you would have found that 1 meter is the same as 3.28 feet. All right, so I want to go from 1 to 1.5 meters. I'm going to line up my units. And so I do that by multiplying 1.5. So in order to figure this out, I have to multiply 3.28 times 1.5. And when I do that, I get 4.92 feet. So what does that mean? Molly is this. So if Molly's 1.5 meters, Molly is also 4.92 feet tall. Shauna is 5 feet tall. Now that they're both in the same unit, feet, I can tell that she is taller. So I just have to convert them into the same units, and I can do so using my ratios and my proportions and what I know about that. All right, thanks for following along, 6th graders. We're going to stop there and then do some practice problems. Thanks for working.